together. K1 is equal to negative K3, K2 is equal to K3. So if you use K1, K2, K3, you will have negative K3, K3, K3. If you want K3 is equal to negative 1, for example, or for 1, or for 2, any number, you will have one of the images of the solution, which is 1, negative 1, and negative 1. This solution set in particular, it's not all zeros. This is the values of K1, K2, K3, which means this combination, so it's linearly independent. Remark, just a sec. If I multiplied 1 by the first vector, and the negative 1 by the second vector, and the negative 1 by the third vector, what's gonna be?
0.
It's equal to 0. So the results of K1, K2, K3, by the idea, which one of them is dependent on the others? Which one of them can be a linear combination from the others? This is before its time, but I will give it to you at this time. Okay? Farid, look to the pivots of the columns at the reduced echelon form. Look to the pivots of the columns at the reduced echelon form. The first pivot exists, am I right?
Yes.
This is the first pivot, yes? Of the first vector. So I will choose the first vector to be with me in the linearly independent set. The pivot of the second vector or of the second column will exist in its place, am I right? So this is vector 2, which means this guy, this one, and that one, those two vectors, okay, are linearly independent. What is the pivot that are missed in this reduced echelon form? The third pivot, so the third vector can be generated from these two vectors. Now I know which one of them is a linear combination of the others. The first one is linearly independent, okay? The second similar line. The third can be simply generated from both of them. تعال بص كده, this problem is really very simple. If you multiply the first one by 1, I believe, and the second one by negative 1, okay, those are the coefficients. 1 and negative 1, you will get the third one. You will get the third vector. Do you read what I'm saying? You understand what I'm saying? So the third vector in this problem is a linear combination from the first two vectors. Okay, but we will go through it down the road. But just in case we are here, so I thought just to give it to you. Which implies that we can write a vector B as a linear combination of the remaining vectors. In R3, this sequence is linearly independent. In R3, that's the canonical form of R3, so it's linearly independent. Also, in any k to the power of n, the canonical form will also be linearly independent. Okay, for any m by n set of matrices, the bunch of matrices E11, E12, blah, 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 all of them are also linearly independent sets. Okay, in the vector space ABC, where A is equal to 2B plus C, of course, if I make the substitution, if this can be substituted of 2B plus C, you will be able simply to get those two vectors, which are the generators of this vector space. صح شباب؟ عارفين ازاي بعملها طبعا، صح؟ بشيل ال A واحط 2B plus C, so it's gonna be 2B and the B and 0, then I will have the other one which is C, 0 and C, so those are the two vectors. تحبوني اعملها؟ اوكي واضح. Okay, is linearly independent. تعال بص كده for those sets. The set Kn of sequences xn, xn minus 1, blah 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 is linearly independent. For R2, بص. For R2, 1 and 0, 0, 1, negative 1 and 3, negative 3 and 4, those are dependent set of vectors. Because simply I can generate this vector from those two vectors. It's very simple. I will multiply the first by negative 1, the second by 3. So it's a linear combination. Am I right? So it's linearly dependent. Also, the third one can be generated from these two. So this is a linearly dependent sequence. Also, this guy is a linearly dependent sequence of vectors. This is a linearly independent set of vectors. I can't generate any one of them from the other. I can't. Okay, simply I can't. Okay, 1 and 0 is linear independent sequence. Remark, if this is 0, if this is 0 and 0, it's going to be linearly independent. And that's from the statement. The beginning of this part, there were a statement. If I have just only one factor.
Why is it independent? Like we can't generate any.
From this one, I can
From the
generate.
0, 0.
From the 0, 0, I can generate any vector from 0 and 0. Because simply, if I have any numbers and multiplied by the scalar value of 0, you will reach the origin. This is why the origin by itself, it's supposed to be a sub-vector space or a vector space from itself. Okay, we can stop here or continue. What do you think? What's the time right now? No, there is plenty of slides.
Still have 25.
Okay, let me do this problem and we will see. Here in R4, let's apply the linear independence criteria to check if this sequence, which is, I'm talking about R4, but I'm giving you how many vectors? 3 vectors. It's okay. The 3 vectors are, those are treble 1, negative 1, and so on. Are they linearly independent? How to check this equation? I will do exactly the same. So I will do a homogeneous system, taking this 3 vectors, and I will put them. And this system will be 4 rows in how many variables? 3 variables. So it's an overdetermined system. And then I will try to work my way out. Okay, here's alpha 1, alpha 2, alpha 3, and it's supposed to equal to 0. And this will form, as we spoke, a system of equations. In how many variables? Just only 3 variables. I will try to go through the augmented matrix. That's the augmented matrix. First the vector, second and third vectors. I will try to reach a reduced echelon 4. Once you try to reach a reduced echelon 4, you will find that the rank is going to be 3 or less than 3, even. Okay? It will never stay at a rank of 4. If you remember, or if you remark, I can work for the homogeneous systems on the main matrix, which is the coefficient matrix, or work on the augmented matrix. Both of them will be the same. Because you are simply going to add a vector here, a column, with 0 numbers, so it's not going to make a change. If I search for the rank, I will be able to get the values or the expected values. Do you read me? فاهمين أنا قصدي إيه؟ مش واضح أنتوا فاهمين أنا قصدي؟ يعني بدل ما اشتغل على augmented matrix وازود عمود كامل بزيروز، أنا ممكن اشتغل على الكوفيشنت ماتريكس مش هيحصل معايا فرق. لأن دايما هيبقى الريزلت ماتريكس بيساوي كام؟ بيساوي زيروز. بس أنا شخصيا بفيل مور كومفورتبل إن أنا أحلها كده. يعني داخليا يعني. أوكي؟ تحبيني احلها لك اكملها ولا خلاص؟ ها؟ It's okay. So some simple computations allow us to check that a rank, once you try to play with it, the rank will end up having 2, which means they are linearly independent. If you try to move your way in order to get a reduced echelon form, the rank is not going to even by 3, it's going to reach 2. Okay. Proposition. Let E be a vector space and U1 be vectors of E. The vectors U1, UR are linearly independent if and only F for every vector. That's a linear combination of the vectors. That's for if the coefficients of the linear combinations are unique. So that's linearly independent. Proposition. If S is U1 up to UR be a sequence of vectors of a vector space and the S dash be a set of vectors by a sequence obtained from the process of row operations, so previously described, then S is linearly dependent, respectively dependent or independent. It's not gonna make a difference. If and only F, S dash is dependent. So if you start with S as a dependent set and you make your row operations, then each you will have linearly dependent set. And if you start with linearly independent, also it's not going to change. Bottom line from this subparagraph is doing the row operations on a set of vectors, it's not going to change the nature of these vectors. Because simply you are working with an equivalent set of vectors. Okay? Let E be a vector space and U1 up to U are linearly independent vectors of E, and the V belongs to E is not a linear combination of the vectors above. So U1, V in specific is not a linear combination. Then the set U1, UR plus V are linearly independent. And the sets of U1 up to UR, it is not a set, is not a subset from U1 up to V, which means I can increase the size of the generators of a certain vector space. What's stated in this paragraph? If I have U1 and UR, those are set of linearly independent. And I have another vector V, which belongs to the same vector space. And this V vector is not a linear combination from this set. Okay? It's a different than them. If I added it to this bunch of vectors, those generators were not going to do the same vector space. شباب نظرة العين دي معناها انك مش معايا. لو انا عندي مجموعة من الفيكتورز, if I have a bunch of vectors, they are linearly independent, so they can generate a certain vector space. If I have another vector, and this new vector is not a linear combination from them, يعني مختلف عنهم, it's different than them, and you added it to this bunch of vectors, they will generate a vector space different than the name. Okay? That's what's explained in here. Which means I can increase or decrease the size. Now I'm going to talk about, in specific, the basis and the dimension. The basis, it means, let E be a vector space, and U1 up to Un, a sequence of vectors of E. We say that U1 up to Un is a basis of E if it is a generating sequence of every vector in E. This is number one. And is linearly independent. So how many conditions is required in order to get a basis of R3 or of any vector space? Two things. Number one, those set of vectors are linearly independent. We know how to check the linearly independence. And those set of vectors, they can literally generate any vector belongs to E. So how many conditions? Two conditions. Usually, if the first, in most cases, if the linearly independent condition exists, they will be able to generate everything. Because simply linearly independent, it means the matrix of the vectors can reach a reduced echelon form. Once it is reaching a reduced echelon form, which means a unit matrix by the meaning, that's what I meant by a reduced echelon form, standard reduced echelon form, that means it's linearly independent, so the rank is fixed. Once the rank is fixed, you will be able to generate any other vector belongs to E, okay? By default, if E is the origin, then the empty set is a basis of E, and that's a statement. Okay. In R2, the following statements are true. 1 and 0 and 0 is linearly independent generating set of R2. Of course, if you try to get K1 times 1 and 0 and K2 times 0 and 1, the matrix will be a unit matrix, so the solution will be K1 equal to 0, K2 is equal to 0, so they are linearly independent. And also, this set, which is 1 and 0 for first vector, 0 and 1 for second vector, can generate literally any vector in 2 by 2. Any vector will have two components. The first is A and the second is B. Both of them belongs to the real set. If you try to solve this system, it will give you a unique solution. That's the first value is A, the second value is B, which means that you can generate any vector in R2. فريق تاني, any vector in R2 هيبقى شكله عامل ازاي؟ ده R2. Any vector in R2 can be A and B. So simply, I can generate K1 V1 plus K2 V2 for A and B. From this equation, I could make this augmented matrix. ده اللي انا بعمله عشان اجيب الاوجمنتد ماتريكس. خدت السيستم ده وعملت بيه substitution. V110, V2011. Once you solve this system, it means that K1 is equal to A, K2 is equal to B. So this set, which is 1 and 0 and 0 and 1, can generate mean R2. ده biologic, صح؟ طيب, how many vectors in this set, in the generator? How many generators? 2. So this is a second, the dimension is equal to 2. So R2, its dimension is 2. And how many vectors can generate R2? For this basis, the canonical basis, 2 vectors, 1 and 0 and 0 and 1. Same way like we'll go for just chasing something like this. Of course, chasing something like this, it's 1 and 0, 0, 1, negative 1 and 3. Those are linearly dependent set, not linearly independent set. Okay? But this linearly dependent set, I can shave it to get a linearly independent set just by removing this guy. Okay? So I'm starting this set and it is not linearly dependent. It's not a basis for R2. I can get vectors from R2 from this set of vectors, okay? By K1, K2, K3. But the basis or the optimal base that will develop R2 out of these 3 vectors, it will happen when I erase 1 and the negative 3, okay? So once more, it is linearly dependent, generating sequence of R2. I can generate any vector, but it's not linearly dependent, okay? I can reach the linearly independent. We know how. Okay, 1, 1 and 2, 2 is neither generating sequence, ما هي generating sequence, خلي بالك of R2, nor linear independent. طبعا ما هيش linear independent لأن الفيكتور ده أقدر أجيبه من ده simply by multiplying by 2. طيب ليه it's not generating sequence؟ لأن مثلا الفيكتور اللي هو 1 1 ما اقدرش اجنريت منه الفيكتور 5 and 0. تقدر تجنريت من الفيكتور 1 and 1 الفيكتور 0 and 5؟ ما تقدرش، لان انت تقدر تجنريت لما بتضرب كونستانت فاليو في الشيب بتاع الفيكتور فهيطلع ريزلت، صح؟ فيبقى اذا ده ميسنج فيكتورز فايتس نوت gonna be a generator. So these are the possible cases. So 1 1 is not generating sequence of R2, but it is linearly independent. فعلا 1 and 1 ده linearly independent. صح؟ انتوا تايهين مني. نظرة العين دي معناها انك تايه مني. Stop. I'm not gonna go further, but I will try to summarize it. The new topics. If I have set of vectors, I can discuss if they are linearly dependent or linearly independent. How to check this point? Really very simple. Just forming the augmented matrix for a homogeneous system out of these vectors. If the only solution, if you have a unique solution, that means they are linearly independent. If you have infinite number of solutions, that means you are linearly dependent. خلصنا من الجزء بتاع independence. Why it is important to study independent and dependent sequences? The most important thing about this part, they are going to affect in the basis. What are the bases? The optimal number of vectors that can generate a specific vector space. يعني العدد اللي أقل ما يمكن اللي يقدر تجنريت R2 أو R3 أو whatever أي نوع من أنواع الفيكتور سبيسز. طيب الجنريتورز دول لازم يبقى فيهم كام كونديشن؟ معايا فريق 2 conditions. رقم واحد انهم يبقوا ايه؟ linearly independent. Number 2, they have to be able to generate any vector in this or any object in this vector space. Okay, these are the 2 conditions. The slide that we are in, this slide, let's look to the first 2 vectors. The first set of these 2 vectors, they can generate R2. Why they can generate R2? The 2 conditions are here. Number 1, they are linearly independent of each other. You can't get this vector out of that vector and vice versa. So they are linearly independent. This is number one. Number two, 1001 can generate literally any vector. Any numbers they can generate. How to know they are able to generate any value? Just simply solve again the homogeneous system, but without the zeros, both A and B, where A and B belongs to R. If this gonna give you a unique solution, لو ده هيدي لك unique solution، يبقى طبعا لو هم linear independent، يبقى ده معناه generators. يبقى إذا the first case is okay. طيب لو أنا جيت أبص على second case, these three vectors، هلاحظ in these three vectors the first condition is not applied, which is linearly independent, because simply one of them can be generated from the others. ده اقدر اجيبه من الاثنين التانيين. But it can generate R2. يعني الثلاثة دول يقدروا to generate R2. أي numbers in R2، أي vectors in R2 I can generate them. Simply حط لي قدام ده زيرو على طول، وحط الفيرست نمبر هنا والسكند نمبر هنا، يطلع لك R2. صح؟ يبقى they are generators، بس هم مالهم؟ linearly independent. دول فيهم حل. ايه الحل؟ erase ده. خلاص رجع تاني زي اللي فوق. طب هيريز الفيكتور ده ازاي؟ I will try to solve a system of equations homogeneous. I will reach the reduced echelon form. I look to the pivots. يبقى every pivot is pointing to the vector that you should keep, and the missing is gonna be the third one, which means it's a linear combination. طيب لو أنا جيت for the last case 1 1 and 2 and 2. First thing, this vector or this set, it is dependent because this vector can be generated from the other. The second point also is missing. Some vectors in R2 you cannot generate from either these two vectors. بعض الفيكتورز مش هتعرف تجيبهم زي 0 1 1 and 0. بلاش 1 0 1 and 5 هتجيبه ازاي؟ معايا؟ مش هتعرف تظبطه، مش هيطلع لك 1 and 5. يبقى it's not generating. So bottom line, for a basis it has to be number one linear independent, number two they have to be generating set. I will stop by this proposition. I'm not gonna do anything else today, but please go through the results that we the topics that we started from vector spaces. Farid, I've sent you the print screen from the email that arrived to me, and in it the next exam, the second midterm, will cover everything for all the rest of our course. Okay? Thank you very much. I will see you next lecture, inshallah. Thank you. Bye bye.